This is 12.2 and 12.3. If I had the equation y equals x squared, the graph of that would be a parabola. So all x squared graphs are either a smiley face parabola or a frowny face parabola. And this point here is called the vertex. So the vertex is centered at the origin. And then if I were to make a table of x and y equals x squared, if I plug in 0 for x, I get 0. If I plug in 1 for x, so I stick a 1 there, 1 squared is 1. Also, -1 squared is also 1. So the first 2 points are going to be over 1 to the right and up 1, over 1 to the left and up 1. And then if I plug in 2, 2 squared is 4, and -2 squared is also 4. So we go over 2, up 4, over 2, up 4. And that gives us the graph of the parabola. So it's pretty simple. Over 1, up 1, over 2, up 4 on both sides. Okay. But what if I want to move the parabola left and right or up and down? Well, to move the parabola left and right, I'm going to add a number to the x. And to move the parabola up and down, I'm going to add a number outside the x squared. Okay. So this says I'm going to change the x by 2, and I'm going to change the y by 1. However, the transformations on the x-axis always work in the opposite direction from what you would expect. So x minus 2 is actually going to move 2 units to the right. But the minus 1 on the outside is going to work exactly like you would expect it to, and it would be down 1. So the vertex of this parabola is at 2, -1. And then it just follows the same pattern. Over 1, up 1, over 2, up 4. Over 1, up 1, over 2, up 4. And that is our parabola. Okay. So here, x plus 2 means the vertex is going to be left 2, and a plus 3 on the outside means the vertex will be up 3. So left 2, up 3, that's our vertex. And then over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4, and over 2, up 4, and there is our parabola. So you have to plot 2 points, you have to plot the vertex, and then 2 points to the left and 2 points to the right. All right. Okay. Well, what does the number in front of the x squared do? And that changes how tall it is. So if I had y equals x squared, that would just be a regular shaped parabola. But if I had y equals 2x squared, then that 2 is going to make the parabola twice as tall. So instead of over 1 up 1, it's going to be over 1 up 2. And instead of over 2 up 4, it's going to be over 2 up 8. And that's going to make the parabola taller. Now, it sort of looks like the parabola is skinnier, which I guess technically is true, but the transformation is actually a vertical stretch, not a horizontal compression. So a 2 out front is going to make it twice as tall. Okay. What if I had y equals 1/4 x squared? So now, instead of over 1 up 1, it's going to be over 1 up 1/4. and that's going to make the parabola shorter. Okay. Well, what if I had y equals negative 3x squared? So that's going to be a super skinny parabola. Well, I just said skinny. A super tall parabola, and the negative is going to flip it upside down. So it would look like this. All right. So choose whether each is positive or negative. So the first one is negative, and then positive, and then negative, and then positive. And choose the coefficient that is closest to 0. So that will be the shortest parabola, whether it's positive or negative, which is going to appear wide. So which parabola is the shortest? And that would be the B parabola. And choose the coefficient with the greatest value. That will be the tallest positive parabola. So that's going to be D. All right. Okay. So this time, instead of graphing a parabola, we're going to graph the square root of x. And this function here is the square root, negative square root of x. I want to move that left 2 and down 3. So negative square root of x. The left is going to be affected by what's on the inside, and it works backwards. So left 2 will be plus 2. And then down 3 will be a minus 3 on the outside. Okay, let's do another one of those. So my parabola is negative 1/2 x squared. So I need to put a number there and a number there. And this graph has moved 4 units to the right. So minus 4 because it's in the opposite direction. And then up 3 will be a plus 3 on the outside. Okay. Oh, this one you won't know how to do. Yep, I'm going to take that one off. Okay. All right. So the vertex is negative 5, 6. So y equals some number times x plus 5, because I went left 5, squared, and then minus 6 on the outside because I went down 6. And then if this was a 1, it would be over 1 up 1. But this one is over 1 up 3, so that number is a 3. If it was upside down, then that number would be a negative 3. I think some of these do get just a hair harder, so let's do several of them. Okay. So y equals negative some number, and then x, we moved right 1, which will be minus 1 squared, and then we went up 3, so plus 3 on the outside. Okay. And normally it's over 1 down 1, but this one is over 1 down 2. So that number is going to be a negative 2. Do you want to see more of those? Yeah? Okay. All right. So y equals something x. We went left 2 for the vertex, so plus 2 squared. and then up 4. And normally the parabola is over 1, down 1, but this is over 1, down 1, 2, 3. So because it's upside down, it gets a negative, and the leading coefficient is a 3. All right, get to work.